Any concerns about the difference quotient for any type of function, polynomial, radical, anything? Anything? Okay. Oh, it's the 30th today, right? Okay. Now, I would like to continue our discussion on this particular function. Okay. So we're going back for a moment, back to the graph we had before. So this is our f of x. We had p here, we had q here, and we remember the coordinates, right? P had x comma f of x, and q had x plus h comma f of x plus h. We remember that. Yes? Okay. And then we drew the secant line. We found the slope. And this was the slope for a particular function. So we had a function that we picked, the square root of 2x plus 1, and we determined that the difference quotient is this. I'm just copying it here. You don't have to copy it again because you have your notes. Okay. Perfect. So now imagine that I bring point Q closer and closer to P. Notice that I did not put the equal symbol. We mean approaches. So this is approaches. As Q approaches P, what happens to H? Awesome. Do you all agree? Because this is exactly what we had. This was the distance called H, correct? So as I bring Q closer and closer to P, I bring it so that it's not P, but it's close, then H definitely approaches 0. Can I say now that the secant line PQ, if I do all this, the secant line PQ gets closer and closer or approaches what? Let's take a look. So this was the secant line. And as I bring Q closer and closer to P, this is what happens. What happens to the secant line? So it was this initially, but I'm bringing Q closer and closer to P. It becomes the, no, it's still a line. It's still a line, but the secant line becomes the at P. Awesome. It becomes the tangent line at P, right? We imagine that. So we started with this, which was a secant line, and now this point gets closer and closer, closer and closer to P. I'm not saying that they are equal. I'm only saying that I started with a secant line, and as Q gets closer and closer to P, then the secant line PQ gets closer and closer to the tangent line at P. We see that? Yes? Very good. So now here's another question for you. Then what happens to the slope of the secant line PQ when I bring Q closer and closer to P? What will that approach? Absolutely. Absolutely. It will approach the slope of the tangent line at P. Okay. So now I would like to look at this particular concept for what we just determined. Okay. So what happens to this, to the difference quotient for this particular function as H approaches 0? What do you think it will equal to? Look at the expression of the difference quotient, completely simplified. And as H approaches 0, what will 2H approach? Correct? And then what am I, see, I should not ever put the equal symbol. So as H approaches 0, then 2H approaches 0, and then what is left? There is a 2 at the top. I have the square root of 2x plus 1 plus the square root of 2x plus 1. How much is an apple plus an apple? 2 apples. Very good. So this is 2 over 2, the square root of 2x plus 1. Of course, I will simplify, and I get 1 over the square root of 2x plus 1. Now the question is, for a moment, the question is, what does this represent for this function? Before you answer to that question, I'd like to come back to function f of x, which is the square root of 2x plus 1. And I would like you to tell me, what do I have to perform, what calculations I have to perform in order to find the domain of this function. What do I have to write? What type of function is it? Square root or radical? Yes, square root, perfect. What do I have to write? When does the square root exist? Or? Good. So if it's the square root of a positive or 0, so then I have to write something and solve. What will you tell me to write? Excellent. That's all I needed. 2x plus 1 is greater than or equal to 0. I move 1 to the other side, divide by 2. So this is x greater than or equal to? That's it. So then the domain will be, can anyone tell us the domain then? So I can write it in interval notation. Stop me if you have questions, anytime. I only have to write this in interval notation. How do I write it? Very good, awesome. Good. So now I'm coming back to the question here. What is this? What does it give? So let's go back to the previous notes, and we said that the difference quotient is the average rate of change of a function, in this case the square root of 2x plus 1, between 2 points, P and Q. Okay, but now here's my question. I said that age approaches 0. So I kind of have only 1 point now. So what will this represent in that case? When age approaches 0, what will this give? Will give the slope of the tangent line to the graph of this function. At which point? Awesome. Very good. So 1 over the square root of 2x plus 1 is the function that gives the slope of the tangent line to the graph of f of x, which is the square root of 2x plus 1. Something very crucial, very important follows right now. If I stop here, this is false. I have to continue. Say it again. Oh, we know that. So this is the function that gives the slope of the tangent line to the graph of the function everywhere on the domain of f of x where the tangent is defined. Where the tangent exists. So that's why we determine the domain. Can you tell me where will this function not exist? Remember, this is the domain of the function. This is a function that we created that gives the slope of the tangent line to the graph of this at any point where certain conditions are fulfilled. So where will this not exist? Yes, Tom?
Anywhere with the value less than -1.
Correct. That's very clear because this is the domain of the function. That's very clear. However, there is one value at which the function exists, but its tangent, its slope of the tangent does not. Yes.
Would that be -1/2?
Of course. X cannot equal -1/2. Very good, Bryce. So here's the graph of the square root of 2x plus 1. The domain is -1/2 to infinity. If this is -1, this is the square root of 2x plus 1. So now let me show you tangents at any point you want. So if you say this point, show me the tangent. Okay, fine. Then you can say at this point, at this x value, for this x value, show me the tangent. Fine. Then you can say, show me the tangent for this x value. Yes, no problem. But there is one point in which I have to show you this. But that is a vertical line. What is the slope of a vertical line? Undefined. So a function, this function is just a regular function, square root. This will be its derivative. That will give us, we'll talk about it later. This will be the derivative of this function. However, at the point of -1/2 comma 0, the derivative does not exist. So the function will not be differentiable there. So we will be able to determine, because I have to have a number, we will be able to determine the number that represents the slope of the tangent line at any point on this graph. And it will be given by this function, with the exception of -1/2, where the tangent is vertical. Okay? So now if I ask you for x equals 1, find the slope of the tangent line. What would you say? How much is the slope of the tangent line when x is 1?
So 1 over the square root.
Of course. With no calculations whatsoever. One more. Let's say when x is -1.
Slope is 1.
The function doesn't even exist at -1. How can it have a tangent, right? If it's undefined, it cannot have a tangent. Okay, last one. Let's say x equals, give me a number.
27.
Which one?
27.
27. Okay, so what is the slope of the tangent line? Let me show you the function. So 27 times 2 will be 54. 54 plus 1. So it's 1 over the square root of 55. That would be the slope of the tangent line at the point where x is 27, comma, whatever. Okay? Good. So now let's start finally what we want to complete today. So if you remember, I said that this is your summary. This is what we go by, and it has absolutely everything in chapter 2, and then I'll have another packet for you for chapter 3, 4, and 5. So this is what we're trying to do today. So let's start with 2.1, which is tangent and velocity problems. Anytime you have a question, please don't wait. Please ask. Okay? So tangent, velocity problems. So please give me a quadratic function. Any quadratic function that you can think of.
X squared.
Yes? X squared?
Plus 1.
Let's say plus 7x minus 14. Just spice it up a little bit. Very good. Now please give me a point. Say it again. Okay. How much is the y coordinate?
3.
I can't. It has to, we have to determine the y coordinate. We can't just say, oh, here it is, 0, 3. No, 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 no. I have to plug it in. Otherwise, it will not be a point on the graph, right? So 49 plus 49, that's 98. And 98 minus 14, 84. Correct me if I'm wrong. So 49 plus 49, 98. 98 minus 14, is that correct? Perfect. So now I would like to determine, so find the slope of the tangent line at P. If this function, if this function is a distance formula, what will the slope of the tangent line at P represent? If, I said, if it is a distance formula, what will this represent then? Not only the slope of the tangent line at P, but also the velocity at P, the instantaneous, very good, instantaneous velocity at P, correct. They are both the same. The slope of the tangent line to a point, to a graph of a function at a point, and the instantaneous velocity, if this is a distance, are the same. Perfect. Good. Like before, I have a point P. What do I need? I don't know how to determine yet. I don't know how to determine the slope of the tangent line to the graph of a function at one point. I have to create another. So let's create another. So if P is P, then let's create point Q. I will give you X and you will give me Y. What is the Y value? What is the Y coordinate of point Q? If the X coordinate is X. Of course. Very good. Always remember that. We cannot pick two different values. We have to pick X, and then we determine the correct, or calculate the Y coordinate. Perfect. So now I have a starting point, because I don't know how to determine yet the slope of the tangent line to the graph of a function at one point. I don't have that algebraic possibility. So I have to create another point, and here's the point Q. I will be able to find the slope of the secant line, as we did before. And how do I write the slope of the secant line? Can anyone dictate the slope of the secant line? And you dictate and I'll write.
So X plus H.
True, but we already have, you're correct. You're correct. Let me tell you, Tom, let me explain. If this were X and this were X plus H, that's exactly what I would have done. And we will do that. Right. But we selected 7, 84. And then Q is X, f of X, because I want you to see the other simpler option with a number in there.
So f of X.
Yes, let's copy it. Oh, let's write it first for everyone to see. So it's f of X minus 84 divided by X minus 7. Very good. And now all we have to do is plug in the function. So it's X squared plus 7X minus 14. And minus 84 divided by X minus 7. So far, so good? Are you with me? Any questions? Please, please. Joe, anytime.
Where do you get the slope of secant?
Okay, you're right. I did not specify. I thought it was clear. I'm sorry. So f of X minus, that's fine. No, you're right. I should have put that PQ. Oh, so what do you?
I was wondering where you get the slope formula, and you told me it was the slope formula.
Oh, yes, it's y2 minus y1 over x2 minus x1. Good. So I copied x squared plus 7x minus 14 and minus 84 and x minus 7. I'm going to try and simplify this as much as I can. So I have x squared plus 7x, and this is minus 98, is it? Divided by x minus 7. So far, so good? Okay. Now I would like to plug in this expression in the graphing calculator. And I would like to get as close as possible to 7, right? So as we did before, here's my point 7, here's my point Q, and I want to bring Q as close as possible to P7, 84, because this is the secant line, but I want to change it into a tangent line. And I want to determine the slope. This is the slope of that. So right now it's the slope of the secant line, but if I bring x closer and closer to x of p, which is 7, if I bring x closer and closer to 7, then I will determine pretty accurately the slope of the tangent line. So let's do that. So here it is. Oh yeah, it started here. Sorry. Okay, so in y equals, we are putting in the slope. Don't forget parentheses around the top. Parentheses around the top, x squared plus 7x. If you need any help with the calculator, please raise your hand. I'll come over and help you. Minus, no, it's not minus, it's plus, sorry. So plus 7x minus 98, and everything divided by, in parentheses again, x minus 7. So we entered a function that represents the slope of the secant line. And my next step would be to go to second and table set. This always goes back to default. So I have to change the independent variable to the ask mode. For some reason, the software always goes back to auto. So we go to second and table set, and we will change the independent variable to ask mode. And now all we want to do is go to second and table. Okay, so one more time. We have the point P, 7, 84, and I have point Q somewhere on the graph of the function. Where do you want to start? How far away do you want to start from 7? For x equals 8. Perfect. I would have said the same thing. Good. So the slope of the secant line PQ with x being 8 is 22. Now I would like to get close. I want to go to 7.5. I want to get closer. I want to get to 7.1. Can I put in 7?
No.
No, because the denominator will be on 0, and of course, the whole thing will be undefined. Error. I can't get anything. Good. So I want to be even closer than 7.1. I want to be at 7.01. Then I want to be at 7.001. You understand what's happening now, right? So this is my P with x coordinate x, and now Q is so close that I cannot even show you how close it is, right? I can't picture that, 7.001. Okay, so I got tired of this. What is 21? At P. Because Q now is almost on top, and not exactly, but almost on top of P. I made Q so close to P that you cannot even see them. Being at a distance. There is no distance between them. So this is nothing else but the slope of the tangent line to the graph of the function you picked. So let's put in writing a couple of things, and we'll go to an example from the book, and then we can continue. So this is what I would do. I would write here 7, I would write here 8, and then a couple of values in between. Not too many, because it's very clear. So the slope of the secant line between P and Q at 7, I copied it here, is 22. Then at 7.5, I copy 21.5. And then I go as close as possible, let's say 7.001, and I got 21.001. And at 7.000000, and so on and so forth, I got 21. And you can put other values in there if you want to. So now we know that the slope of the tangent line at P is definitely, for this function that you picked, is definitely what? What is your assessment? The slope of the tangent line at P, we have to write it. How much? 21. 21. This is all you have to do in the checklist, the summary. In 2.1, you have these two. I created a function for you. All you have to do is redo the problem. And I'm going to show you one more from the book. And item number 3, it just says just look at problem number 7, but we are going to look at a problem together. Okay? So that will be 2.1. So let's pick another problem. If you have your book, you don't have to. If not, I will pick. So let's say problem 4 on page 86. Before we continue, any questions for me? Any questions on? Yes, please, Joe. Go ahead.
About this packet.
Yes.
So like, I might have copied what you wrote, like up there in that first.
That's fine. You will keep this. You don't have to turn this in to me. So this is a summary for you. There is really not enough room to write in here. But you will have to turn in this in your own handwriting. That's fine. If you want, I can give you another. If you want to keep a fresh one. I have plenty. Okay, 4 on page 86. We're given a point, P, 0.5, comma 0. It says it's on the curve y equals cosine pi x. If Q is the point, what do you think Q will be the point? Which point? I know you don't probably have the book. What do you think Q will be? Look back at what we just did and say, I know Q will be, comma, yes, or cosine pi x, of course. Very good. Use your calculator to find the slope of the secant line PQ. Correct the 6 decimal places. Find the following values of x for the following values of x. So here it is. Right here, I picked 4. And we're given some values. And then part B, it says, using the results of part A, guess. We don't have to guess because we can be as close as possible as we want, as close as we want to that. Guess the value of the slope of the tangent line to the curve at point P. Of course, this is exactly what we just did, but with a simpler function. Ready? I'm going to copy their values, their x values. However, I'm going to copy them correctly, meaning they're all over the place. As you see, 0, 0.4, 0.49, 1, 0.6, 0.51. I'm going to put them in the correct order from left to right. So, 0 is the first one. The next one in line is 0.4. Next one is 0.49. Next one is 0.499. Of course, the next one is our 0.5. The next is 0.501. I ran out of room, so I'm going to continue underneath. The next one is 0.51. The next 0.6. And the next one. Okay, ready? Can anyone give us the slope of the secant line PQ? Can anyone dictate the slope of the secant line PQ? And I will write it.
Cosine pi x
Awesome.
minus 0.
Awesome. Yes, I don't have to write it, but for everyone to see. Very good. Over
X minus 5.
0.5. Perfect. Yes, that's fine. Are we in agreement with this? Thank you, James. Are we in agreement with this? This is the slope of the secant line PQ, correct? Okay. I would like to put this in the graphing calculator. Before that, let me explain. I want to avoid a confusion. Okay. So what will be the first x you will enter? You will enter 0, correct? So between 0 and 0.5. Then you will enter 0.4, correct? Because that's PQ. So this is our Q, and it moves everywhere. This is our Q, right? So we will have f of 0 minus 0, f of 0 minus 0, over 0 minus 0.5. Then we're going to move on to 0.4. Cosine pi times 0.4 minus 0 over 0.4 minus 0.5. Then we're going to have cosine 0.49 pi minus 0 over 0.49 minus 0.5. And then we are going to have cosine pi times 0.499 minus 0 over 0.499 minus 0.5. And we'll continue then with this, and with this, and with this, and with this. Are you with me? Perfect. We understand what we're trying to do. Instead of doing this by hand, I want to put this function in the graphing calculator and get all the numbers right away without having to write down anything other than the answer of those. So let's go to y equals. Let me see where I'm with time here because I want to stop it after an hour. Otherwise, it takes a long time to upload. Okay, the top is only one term, but normally we should put parentheses otherwise. So I have cosine in parentheses pi x, close the parenthesis, and divide by, don't forget parentheses, x minus 0.5. This is, oops, I did something here. What am I doing? Nobody knows. Okay. Okay, so 0.5. Good. So this is absolutely everything we've done in the previous example, which was a very simple quadratic function that you came up with. I just want to repeat the process one more time. Are we all together here? Okay. So this is a slope, right? So now I want to determine the slope between P and Q when Q has x0, then when Q has x 0.4, and so on and so forth. Ready? So with second and table, I put in 0. I put in the next value, which is 0.4. I put the next value, which is 0.49. The next one, 0.499. The next one, I want to put 0.5. Can I? It's not going to give me anything. Correct. 0.501. Next one, 0.51. Next one, 0.6. And next one, 1. Where is 0.5? 0.5 is right here in the middle. Can you just come up with an estimate of the, yes?
Probably pi. Or not pi.
Negative 3. This is the slope. The y1 is the calculated slope between P and Q for different Qs. Okay? So since 0.5 is right here in the middle, what do you estimate the slope of the tangent line at P to be? Your wild guess. It's not a wild guess at all, actually. Negative 3.142. Let's say you can say now to me, well, those points are not close enough to 0.5. No problem. I'll make it as close as possible. 0.5, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, and that should convince you. Or 0.4999999, and that should convince you. Okay? So, of course, the calculator also has some tiny error. You can say it's a very good estimate. If you could say just negative 3.142, I will have to accept it. It's very close. Now, if you want to be as close as possible, see, this is a tiny error that the tolerance of the calculator, right? 0.5 and 0.5, it should not be any difference between negative 3 and negative 3. It should be, or both negative 3.1. But, so all the slopes, I would, on a homework problem, I would write these slopes in here. So I have here for negative 2, for 0.4, negative 3.09, negative 3.142. No, it was 1. Negative 3.142, negative 3.142, negative 3.141, negative 3.09, and then negative 2. And I will say our conclusion is that the slope of the tangent at P is roughly negative 3. If you write negative 3.142, I'm fine too. It's pretty close. Any questions? Any questions? Okay. I think we are ready now to move on to 3.2. Not 3.2. I meant to say 2.2. 2.2 limits. A few minutes ago, I wrote this. That Q can be brought closer and closer to P, which means H approaches 0, which means the secant line becomes the tangent line, which means the slope of the secant line becomes the slope of the tangent line. This is not the way, the correct mathematical way in which we write this. So here's the correct mathematical way. Let's say we want to say that we are trying to find the limit of f of x as x approaches a from either side. So let's say this is our problem now. We're trying to find a nice way of writing the limit of f of x as x approaches a from either side. This is the limit operator. Limit operator. And here's how we write it. LIM, limit of function f of x underneath LIM as x approaches a from either side. And one more time, this is the way we read it. Limit of f of x as x approaches a from either side. We can also have one-sided limits. One-sided limits. There are two possibilities. LIM, limit of f of x as x approaches a with the plus as the power for a. And the other one, LIM of f of x as x approaches a with the power that is negative. What do you think the first one says? Is it the right or the left limit? Yes, because it says with values of a that are larger than a. What will be the other one? From the left, which means with values of a that are smaller than a. Now, the next question I have here is that I would like to look at is look at a few graphs, and then we'll look at the book. So here's one graph for you. We had this before, last time, and we can always go back, for example, to the piecewise defined function we had. So now, again, this is a left-hand limit as x approaches 0. So the limit of the function as x approaches 0 from the left is 2. If I cannot give you a number, the limit does not exist. So if I say infinity, the limit does not exist, but I will write infinity. So a limit exists as long as I can give you a number. I cannot say approximately. I have to say a number, give you a clear number. Say? So here's an example then. This is full and this is open. Will the limit in this case, let's say this is the limit as x approaches a. This is a. Let me use a number. It's even easier. Okay? So limit of f of x as x approaches 2 from either side. What will you say? From the left, you will say it's probably 3. From the right, you say it's probably 5. But what is from either side? Exactly. We write D and E. It does not exist. The limit from either side for this particular example does not exist. 2 more examples before we look in the book. Let's say I have a situation like this. Here's my function. Let's say this is x equals 3. And I'm asking you the limit as x approaches 3 from either side of f of x. What will you say? The left-hand side approaches infinity. Perfect. The right-hand side approaches good. What will you say? Yes. Although it's not a number, although we know that the limit does not exist, I cannot write D and E in this case. I can write D and E in this case. So what will you write in this particular case? So let's say this is 4, limit as x approaches 4 from f of x. What will you say now? For this situation. The left-hand side is, the right-hand side is, so from either side, that's it. In this case, I have no choice. I have to write D and E. Any questions? Okay, I would like to look in the book at some graphs, and then we'll come back to other types of problems. Please choose a graph of your choice. So we can answer the questions. You prefer this? Okay, very good. So this is problem 6 on page 96. Okay, so I'm gonna read the problem to you. For the function h, whose graph is given, state the value of each quantity if it exists. Perfect. So, is it clear? Okay, first one. The limit of h of x as x approaches -3 from the left. Joe, can you shut that door, please? Sorry about that. So the limit of h of x as x approaches negative 3 from the left. Negative 3 from the left. The function values approach 1, 2, 3, 4. Do we all agree? So as x approaches negative 3 from the left, the function values get closer and closer to 4. It does not matter that the function is not defined there. We're not asking the value of the function at 4. At negative 3. We're asked to find what is the trend, which values will the function approach, not what the function is at negative 3. So do not get confused do not confuse the two concepts. The limit is one thing. Whether the function is defined is a totally different thing. They're not connected. Okay? So the limit exists, although the function does not exist at that point. Okay. Limit of h of x as x approaches negative 3 from the right. Negative 3 from the right. Also 4, right? I think. Right? 1, 2, 3, 4, correct? Good. Is that clear? Okay. Next question. Limit of h of x as x approaches negative 3 from either side. 4. Do you all agree? From either side. 4. H of negative 3 does not exist. H of negative 3, at negative 3 there is no full point anywhere. No full point. H of negative 3 does not exist. Limit of h of x as x approaches 0 from the left. 0 from the left. 1. We agree? 0 from the left. 0 from the right. Negative 1. We agree? Okay. 0 from either side. Correct. Because one side goes to 1, the other side goes to 0. Which number do I give you? I cannot give you 2. I have to find 1, and there is none. Very good. H of 0, please.
1.
Exactly, where the full point is. H of 0 is 1. Are you with me, everyone? Questions, please stop me. Okay. Limit of h of x as x approaches 2 from either side. Yes. 2 from either side, its function is not defined, but we don't care. So from both sides, it approaches 2. Very good. And h of 2. Correct. Correct. It does not exist. Limit of h of x as x approaches 5 from the right. 5 from the right.
3.
Very good. 3. 1, 2, 3. Perfect. Now careful. 5 from the left. Let me explain what happens here. It's an oscillating limit. So here's what it does. At that is at 5, right? Okay. At 4 is here. At 4.1 is here. At 4.2 is here. At 4.3 is here. At 4.5 is here. So it will constantly go up and down, up and down. It will not approach any number. So that's why on this side, it's D and E. Any questions? Any questions? Would you like me to write these answers down? Or is everything clear with this problem? Okay, perfect. Now, the next step would be, if you would like, and if not, then we don't need to do that. We can graph another piecewise defined function and answer questions. So there is one in the book, there is one here, and if you say, I got the idea with piecewise defined functions, you don't have to show another example. I will not show another example. Do we need one? Another one, another piecewise defined function. You're going to see it on the test, you're going to see it on the final exam. Yes, Joe?
So I get how to do them, but how do you actually write, like, saying something approaches something?
With the limit operator.
Oh, right.
With a limit operator.
So
No more arrows. We're done.
Okay.
That was the first time when I had to explain and give you the idea. But this is what we use from now on.
Right.
The limit of f of x as x approaches 4. Either from the left or from the right or from either side.
You would just change the sign to indicate.
Yes, if it's from the right, I will put a plus. If it's from the left, I will put a minus. And if there is no power plus or minus, it's from either side. Okay. So then we continue then? Okay. So again, if you want to change that at any point in time, you can tell